because that's also a constant speed. So it's sort of an explanation of how light works, how E&M works, electricity and magnetism, wave nature of light, and sort of the relative nature of space and time. That is special relativity. But if you have to understand accelerating frames, if you have to understand gravitation, then you needed to do more work, which he did. He spent more years working on the next theory, which was the general theory of relativity, which really gives us the more general theory versus the special case of relativity, which is the special theory of relativity. So this is where we will now get an updated theory for gravitation, and we've mentioned this before, but let's see what Brian Greene has to summarize here. And I think he will summarize probably sort of how this perspective changes and whatnot. So by the way, this is the book that we're currently covering. So Newton's view of gravity is the next section, incompatibility of Newtonian gravity. And special relativity is another section here. Einstein's happiest thought. Oh. So it's going to be a little bit of a story time now, which will probably give you a summary of sort of like all of this. So stay tuned and let us enjoy this summary that we're about to read. Newtonian, or Newton's view of gravity. So I was mentioning just a moment ago how we sort of, like human beings, sort of function in the Newtonian mechanics scales, the speeds, the sizes, the sort of even the masses, like those are more Newtonian mechanics describable type of scales. Look, so let's summarize. Yay, Chickpea says tuned. Isaac Newton. So Isaac Newton, still thought of as the greatest scientist ever, really. Born in 1642 in Lincolnshire, England, changed the face of scientific research by bringing the full force of mathematics to the service of physical inquiry. So physics became really mathematical when Newton brought mathematics to it and even invented calculus to do this work. So all of the sort of mathematizing of how we understand this world, this universe, really came with Newton's work. So that's why he's very important. I'm glad we're kind of getting a summary of that here. Newton's was such a monumental intellect that, for example, when he found that the mathematics required for some of his investigations did not exist, he invented it. So when Isaac Newton realized that some of the mathematics that he really needed to work, like basically give a mathematical description of his physics work, he invented that mathematics. So excellent mathematician as well as physicist, quite a combination there, Newton. So this is why he's so very special. And then we sometimes say that, and then he turned 27 or something. So he also did this all at a very young age. So extremely remarkable here. Nearly 3 centuries would pass before the world would host a comparable scientific genius. Of Newton's numerous profound insights into the workings of the universe, the one that primarily concerns us here is his universal theory of gravity. The force of gravity pervades everyday life. It keeps us and all of the objects around us fixed to the Earth's surface. It keeps the air we breathe from escaping to outer space. Right? Baji is taking a bath. It keeps the moon in orbit around the Earth, and it keeps the Earth bound in orbit around the sun. Gravitation. It's me alone again. You know, Chickpea, it is okay to be alone. Isolation is sometimes more fruitful than a crowd. Ask Newton. He thoroughly believed in isolation. Gravity dictates the rhythm of the cosmic dance that is tirelessly and meticulously executed by billions upon billions